Artificial intelligence is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence, but does not have to confine itself to methods that are biologically observable. Artificial intelligence textbooks define the field as the study and design of intelligent agents, where an intelligent agent is a system that perceives its environment and takes action that maximizes its chances of success. John McCarthy, who coined the term in 1956, defined it as the science and engineering of making intelligent machines. Artificial intelligence takes the intelligence of humans, such as perception, natural language processing, problem-solving and planning, learning and adaptation, and acting on the environment and applies them with machines, systems, and virtual objects. In the course of 50 years of research, artificial intelligence has developed a large number of tools to solve the most difficult problems in computer science. A few of the most general are the following: search and optimization, logic, probabilistic methods of uncertain reasoning, classifiers and statistical learning methods, neural networks, control theory, and languages. Alan Turing's 1950 article, Computing Machinery and Intelligence, discussed conditions for considering a machine to be intelligent. He argued that if the machine could successfully pretend to be human to a knowledgeable observer, then you certainly should consider it intelligent. This test would satisfy most people, but not all the philosophers. The observer could interact with the machine and the human by teletype, and the human would try to persuade the observer that it was human, and the machine would try to fool the observer. The Turing test is a one-sided test. A machine that passes the test should certainly be considered intelligent, but a machine could still be considered intelligent without knowing enough about humans to imitate a human. Some of the applications of artificial intelligence are the following: game planning, understanding natural language, heuristic classification, and expert systems. Web is a system of Internet servers that supports specially formatted documents. The documents are formatted in a markup language called HTML that supports link to other documents as well as graphics, audio, and video files. There are several applications called web browsers that make it easy to access the World Wide Web. These servers are connected through the Internet, who carries an extensive range of information, resources, and services. A computer cluster consists of a set of loosely connected computers that work together so that in many respects they can be viewed as a single system. The components of a cluster are usually connected to each other through fast local area networks, each node running its own instance on an operating system. Computer cluster emerge as a result of convergence of a number of computing trends, including the availability of low-cost microprocessors, high-speed networks, and software for high-performance distributed computing. Clusters are usually deployed to improve performance and availability over that of a single computer, while typically being much more cost-effective than single computers of comparable speed of availability. Computer clusters have a wide range of applicability and deployment, ranging from small business clusters with a handful of nodes to some of the fastest supercomputers in the world, such as the K computer. By saying web data clustering, we mean the organization of data circulated over the web into groups in order to facilitate data availability and accessing, and at the same time meet user preferences. It's a grouping of web objects into classes so that similar objects are in the same class by discovering distribution patterns and the relationship between data attributes and employee unsupervised learning.
The main idea is to define case androids, one for each cluster. These androids should be placed in a cunning way because of different location causes different result. So the better choice is to place them as much as possible far away from each other. The next step is to take each point belonging to a given dataset and associate it to the nearest android. When one point is pending, the first step is completed and an Erlang group age is done. At this point, we need to recalculate k new centroids as barycenters of the clusters resulting from the previous step. After we have these k new centroids, a new binding has to be done between the same dataset point and the nearest new centroid. A loop has been generated. As a result of this loop, we may notice that the k centroids change their location step by step until no more changes are done. Hierarchical algorithms start with single-point cluster and upward step-by-step merge cluster until desired number of cluster is reached. One of the most common hierarchical algorithms is Cure algorithm. Cure employs a new hierarchical algorithm that adopts a middle ground between centroid-based and all-points approach. It uses random sampling and partitioning to reduce the input data set. Steps: a constant number C of well-scattered points in a cluster are chosen as representative that catch all the possible forms that could have the cluster. 2. The points are shrunk toward the mean of the cluster by a fraction A. If A equals 0, the algorithm behavior became similar as all points, else Cure reduces to centroid-based approach. 3. The clusters with the closest pair of representative points are the clusters that are merged at each step. 4. When the cluster number increases, we select C points from the two C scattered points for the two clusters being merged. 5. The new points are fairly well scattered. Advantages: Cure can detect clusters with non-spherical shape and wide variance in size using a set of representative points for each cluster. Cure can also have a good execution time in presence of a large database using random sampling and partitioning methods. Cure works well when the database outliers. These are detected and eliminated when they are going very slowly.